Supernova. A supernova is one of the most powerful explosions in the universe, happening when a star reaches the end of its life. In massive stars, the core collapses under its own gravity and then rebounds outward, blasting the outer layers into space. In other cases, a white dwarf star pulls in too much material from a nearby star until it suddenly detonates. These explosions can briefly outshine entire galaxies and create many of the heavy elements found in planets, and even in our own bodies. Hypernova. A hypernova is an even more energetic version of a supernova, linked to extremely massive stars. When the core collapses, it can form a black hole while releasing intense jets of energy that shoot out in opposite directions. These jets are so powerful that they are often connected to gamma-ray bursts, making hypernovae some of the brightest events ever observed across vast distances. Gamma-ray burst. A gamma-ray burst is a sudden flash of extremely high-energy radiation that can last from a fraction of a second to several minutes. It usually comes from the collapse of a massive star or the collision of two dense objects like neutron stars. Even though the burst is brief, it releases more energy in seconds than the sun will produce in its entire lifetime. These bursts are often detected from billions of light-years away, showing just how intense they are. Nova. A nova is a smaller, less destructive explosion compared to a supernova. It occurs in a binary star system where a white dwarf pulls gas from a companion star. As the gas builds up on the surface, it heats up until a sudden nuclear reaction ignites, causing a bright flash. Unlike supernovae, the star survives and can repeat this process over time. Kilonova. A kilonova happens when two neutron stars collide and merge together. The impact releases a massive amount of energy, along with heavy elements like gold and platinum. These explosions are shorter and dimmer than supernovae, but they play a key role in creating some of the rarest materials in the universe. The first confirmed observation of a kilonova came from a neutron star merger detected through both light and gravitational waves. Solar flare. A solar flare is an explosive burst of energy from the surface of a star, most commonly observed on our sun. It happens when magnetic energy suddenly releases, sending out radiation and charged particles. While much smaller than other cosmic explosions, solar flares can still affect planets by disrupting satellites, communication systems, and power grids. Magnetar flare. A magnetar flare comes from a special type of neutron star with an extremely strong magnetic field. When the magnetic field shifts or cracks the star's crust, it releases a sudden and intense burst of energy. These flares can be so powerful that they briefly affect space near Earth, even from across the galaxy, making them one of the most extreme events involving neutron stars. Quasar outburst. A quasar outburst occurs in the center of a galaxy where a supermassive black hole is actively pulling in matter. As gas and dust spiral inward, they heat up and release enormous amounts of energy. While not a single explosion like a supernova, the sudden increase in brightness can appear explosive and can outshine the entire galaxy for a period of time. Blazar jet burst. A blazar jet burst happens when a supermassive black hole shoots out a focused beam of particles and energy directly toward Earth. These jets travel close to the speed of light and can vary rapidly in brightness, giving the appearance of sudden bursts. Because the jet is pointed at us, the energy seems far more intense than it would from other angles. Fast radio burst. A fast radio burst is a brief but powerful pulse of radio waves coming from deep space. Each burst lasts only milliseconds, yet carries a huge amount of energy. The exact cause is still being studied, but many are linked to magnetars or other extreme cosmic environments. Their short duration and mysterious origin make them one of the most intriguing explosive signals in the universe.